Alright, so in this problem, instead of adding our vectors together, we're going to subtract one vector from another. So I am going to go ahead and write down the x and y components of vector m and vector b because we did that in the last video. So vector m has an x component of negative 18 meters and a y component of negative 31 meters. And vector b has an x component of negative 9 meters and a y component of 15.6 meters. So, this is very similar to vector addition, but this time we are going to subtract them from each other, right? So, the x component of our resultant vector is going to be mx minus bx, and the y component is going to be my minus by. So Rx is going to be negative 18 minus negative 9. This is going to give us negative 9 meters. And the y component is going to be negative 31 minus 15.6. This will give us a y component of negative 46.6 meters. I'm going to go ahead and take this back into polar coordinates because that's how it was given it to us. So theta is going to be my tangent inverse of ry over rx. So theta is going to be -79 degrees, but because these are both negative, I need to add 180 degrees to it. So it will be 259 degrees. Now, in order to find the magnitude of the vector, right, I use Pythagorean theorem again. And all of this was covered in the last video that I did. So if you're confused, go review that. So this would be negative 9 squared plus negative 46.6 squared. And notice how I put these in parentheses. Make sure that you use the parentheses on your calculator whenever you're typing it in. Most often people get weird answers because they didn't use enough parentheses. So this is going to be 47.5 meters. So vector r is going to be 47.5 meters at 259 degrees. Well, that was fairly straightforward. Using the visual, right, the graphing method is a little bit more complicated. People get tripped up a lot more on this version, and it's because of that minus sign. So I'm going to go ahead and start to draw this out, right? So if I have my coordinate system, M is 36 at 240 degrees. So 0, 90, 180, 2, that's a 7, 270. So it would be coming off right about this angle. And then what we need to do is we need to do tip to tail, and then we're going to flip it. So I'm going to draw B on there, and then I'm going to flip it. That flip is going to represent the minus aspect of this. So B is 18 meters at 120 degrees. I'm going to forget. So I'm going to draw another little coordinate system on here. So 120 degrees would be about right here, and it is going to be about half the size of M, but this is when I'm adding them together. So whenever I'm subtracting, I need to flip this. So I'm going to imagine, right, that there's a plane right here, and this is a right angle. I am going to flip this vector over that plane. So it will now come off at this direction. See, this is still a right angle. I'm flipping it over this imaginary plane right here. So all of this can go away. Oh no, not that. I still want that. Lord help me. Okay, so now I can draw my resultant vector. So my resultant vector is going to go, right, from the tail of M to the tip of B, and this is my resultant vector. My resultant vector should be 259 degrees, 47.5 meters. This is about 259 degrees right here. And 47.5 meters is going to be longer than M. It is longer than M. So it appears that my solution is correct because I double checked it visually.